Okay, so good afternoon, good morning, or good evening from where you are viewing or watching from. So, in today's lesson, we are going to take a look at the in-depth analysis or the difference between aliphatic and that of aromatic compounds. So, if you look here from this structure we have here, this is said to be an aliphatic structure. Why? Because this contain a chain from all the branch. Like if you look here, we have CH3 being bonded to carbon. Excuse me. This is a bond that is being linked here. That is being linked. So if you look here, you will also notice that they all contain a single bond. Like you see a single bond here, single bond between here, single bond here. So they will be placed on one of the functional groups that we call alkene, which is ALKANE. We say ALKANE is a single bond, and we also said that each single bond contains two electrons. Why? Because at their edge, like here, there's an electron here, and there is an electron also here. So a single bond alone contains two electrons. So if you have double bonds, you have four electrons. If you have triple bonds, you have six electrons. So I hope you get that clearly. So the main purpose of today's video is to get the key analysis or the key point on aliphatic and aromatic compounds. So in short, we can say an aliphatic compound is a compound that contains a chain or a branch structure. Like you can see right here, this is a branch structure because it has something being attached to them here, and also in a linear form. So this can be referred to as an aliphatic structure when it comes to organic chemistry. Hope you have understood that. So if you want to write the same structure for this particular one, but in different form, following the aromatic form. So we can firstly count here. We have one carbon, we have two, we have three, we have four, five, and six. So mostly in organic chemistry, we look at carbon and hydrogen to identify the longest continuous chain or the parent's name. So all those ones you have seen here, like BR is bromine, but when it becomes a substituent or a branch, you no longer call that bromine, you refer to it as bromo. So instead of you saying BROMINE, you will now refer to it as BROMO, bromo, because it has served or it served as a substituent. Okay, likewise, this is chlorine, but when it has been attached to something else in organic chemistry, we refer to it as chloro. So you have bromo, you have chloro, you have fluoro. They are all halogens that are found in group 7 or group 17 of the periodic table. So like I said here we have 1, 2, 3, 4, 5, 6. So the longest continuing carbon chain here is 6. And how do you refer to compound that contains 6 carbon when it comes to organic chemistry? So we refer to that as hexene. So the parent name now will be hexene, H-E-X, or we say hex. Hex because it is our prefix. So right here now to write the suffix here, as you can see, since it contains single bond or between them, we can write A N E. We can write A N E. So this becomes the parent name right here, hexane. Okay. So the next thing is to kind of look at this. If you are counting, if you look here, the first one has no branch or is a substituent, but the second one does. So likewise, if you try to count from this aspect, the first one does not have anything, and the second one does have things be attached to them. So in this capacity, or in this case, you can count from anywhere because the second one has a substituent or a branch. Likewise, this error also, right? So if you had to say 1, 2, 3, 4, 5, 6, you count from this side. if you want to count from this side, you say 1, 2. So the second one, it will also contain a substituent or a branch being attached to them. So in this case, we can count from anywhere. So let's count from this aspect. So the second one here has 2 groups being attached to them. One of them is bromo, one of them is chloro. But both bromo and that of chloro are in the same group. That is group 17 or group 7 of the periodic table. So here now we have the second area here. We have 1, 2. On the second carbon, you have bromo. So you will maintain this. You say 2 bromo. B-R-O-M-O. We said bromo because it is serving as a substituent or a branch. It is not serving on its own. It has been attached to something else. So on the second carbon also you have something we call chloro. So we say 2 chloro, C-H-L-O-R-O. Okay. So the third one here, what do we have here? You have chloro also. So it's 3 right here. So we can say 3 C-H-L-O-R-O, 3 chloro. Then the fourth one here has nothing being attached to it. And the fifth one here has 2 methyl groups that have been attached to them. So we have both CH3 and that of what? CH3. So 4 here now, 5 rather. 4, 5. 5 here we can say 5. What? Attached to 5. We have methyl. Methyl, remember it is da. It is da. It is da. So we can say 5 da. We say da because they are 2 of the same count. So we say da. Da what? Da methyl. 5 da methyl. Then what becomes of the parent name is hexane. So in this case here, if you look here, we have somehow named this structure. So we can now put them together to see if we can, or if we have gotten it actually. So it is what it is. So right here, to combine them together, you should firstly take into consideration that we name them alphabetically. Like you have C, I would say B comes before C and C comes before. We should not look at this diet, this prefix. It should be the main constant is this one, right? The main name. So we start with right here. We say 2 bromo. P comes before C. So we can say 2 bromo. We only have 1 bromo here. So we just put that 2 bromo. B-R-O-M-O, 2 bromo. From B, what do you have next? You have C, which is chloro. And chloro here appears 2 different times. It's on 2 carbon and that of the 5th carbon. The 5th carbon. Yeah, that of the 5th, not 5th rather, but the 3rd carbon. So we can say 2 comma because this first one is this, and this, this first one is this, and this 3 here, we can say command 3. We say da. Why da? Because Korea appear 2 different times, so we use da. Da means 2. So we say 2 command 3 da dr da what? Da chloro. CHLORO. Da chloro what? We can erase this for now to see how best we can place those remaining one there. So here now, the last one is M. P comes before C, C comes before M. But here we should put a da. We should put da because here you have 2 of them there. So we can say fa. We should not say fa command fa because it's on the same thing. So we can say just say fa da methyl methyl. Fa da methyl. What was the parent name? It was hexane. So you can just say HEXANE. So this becomes fa da methyl hexane. So that is it. So we can now move to the aromatic form of this structure. We can write that to see what we get there. So let's keep moving. Okay, so to write the aromatic form of this structure, for which we have already written the aliphatic form, because we say for aliphatic, it deals with chain structure, or that we say something in a line form. As you can see here, this is a chain, a chain, a chain, and also a chain right here. So they can be referred to as aliphatic structure. So when it comes to aromatic, it's discussing something of shape, something that is in a shape form. Let's say, for example, this is a square right here in the shape form right here. So this becomes an aromatic. Anything that is in a shape form, it becomes an aromatic, or something in a ring form like benzene. So benzene, now you have this. If you have benzene like this now it becomes an aromatic form. It is in an aromatic form. So benzene is always in its aromatic form because of the ring form. So it becomes a this. Okay, so if we now want to place this particular structure into the aromatic form, we can go about doing that as a whole. And how can we do that? So we said the parent name here is hexane. It's hexane. So hexane becomes the parent name. So it tells that we should draw a shape that contains 6 edges or 6 points. So let's write this shape right here. Here's the first one. So this is the second one. So this is in aliphatic form. And this 2 now is going to be in the aromatic form. So here now we can say the aromatic, aromatic. Aromatic form of this structure here now. Since the parent's name is hexane, 6, you draw a shape that has 6 edges, which will contain 6 carbons. So we can do this. We can draw this. I'll use a black marker. We can draw this like this. Okay, so when you look here, we say 6 edges. Here is 1 edge, here is 2, here is 3, here is 4, here is 5, here is 6. And each of those edges contain a carbon for which you are not seeing. They contain carbon here, there's a carbon here, there's a carbon. That's what makes it to be an hexane. But if you are naming that, it will sound differently. Here now we attach something called chloro. We'll say chloro. So whenever here was, you hear like chloro, CHL, let's say, excuse me, cyclo, CYCLO, excuse me, a cyclo. Whenever you hear word like cyclo, it means that it's in a shape form. So this now carries cyclo, hexane. So once you hear cyclo, it's discussing a shape form. So right here, the first one has nothing. The second one has what we call a bromo attached to it. So if we want to check from here, from this origin point, if we want to check from here, this becomes the first one. If we want to go this way or this way, it level up. So here now we can say for this first area, we say is the position, initial stage right here. So the second one now, let us go this way. So here the second one here is you continue what we call a bromo. So you can just attach something right here. You can just attach something right here. Right here you put BRO. Then the C tier one here, what it contains? The C tier one here, it contains something we call coral. So this has 2 constituents being attached to it, as you can see right here. So this has 2 right here. So let's assume that there's a carbon right here. So carbon is here, is forming 1 bond right here. It's forming 1 bond right here. That is being linked here and here, making the 4. So carbon forms 4 bonds. So the tail one here, what is being attached there is the same coral. So we say the tail one here, this tail one here, we can say it has a coral. Then the fourth one, what's the fourth one? It has anything there? No, there's nothing here. The fifth one, what it has there, it has 2. So we can just do it like this, and like this we put a methyl CH3 and also put CH3. So this clearly tells us that this this shape here is in a circular form, making it to be an aromatic compound because it's in a shape form. So whenever it is in a shape form, you call them cyclo because they contain a shape form. But if it's not in a shape form, you don't have to put cyclo there. As when we were naming this one, we never put cyclo here because it was not in a shape form. It is in a chain form, so we exclude that from there. So this is the compound for this also is in the aromatic form. It is in the aliphatic form. So that is just their key difference between those two things. So again, we can try to name this here now. We will say this. We will say here the first one has nothing there attached to it. So we count it this way. It's 2. So we just write the same structure or the same name you see here. So it becomes 2 bromo, 2 bromo, 2 comma 3, 2,3 dacro 5 methyl what cyclo. We should add cyclo to this parent name now. We should add cyclo right here, making it what an aromatic compound. We say cyclo CYCL cyclo what hexane HEXANE. So this becomes the name of this particular structure. So we name them differently based on how they appear. So the next thing you should try to understand again is alkane and that of the alkyl group. So we have ALKANE, and we have ALKYL. So logically, this is formed on this. Let's say for instance, Amos and my last name is Momo. So Momo becomes the sum name, the family name. So I'm Amos Momo. My sister is Naomi Momo. So we all carry Momo name. So Momo becomes our sub name. So here now, this is a child that has been attached to this particular one. So example of them could be for this. If you were asked to give one example of alkane, what could that be? You could say methane, right? It's a simple one. METHANE. It can be methane, ethene, propene, butene, pentene, and so on. So if you was also asked to give an example of alkyl, let's say the alkyl group, what could that be? Instead of saying methane, you will drop this particular ANE and replace it with what we call YL. YL. Remember, it starts with ALK, the same thing here, but it ends different as ANE and YL. So to do that now, this will be NETHYL. So once that is done, it's because if this acts as a branch or a substituent, it be referred to as an alkyl group. But if it's on its own, it becomes what? An alkane, right? So this now example here we say CH4 as the formula for methane. This now if it serves as a substituent like you see right here or branch right here, it's 3 here. It no longer 4, so it becomes CH3. So this becomes methyl, this becomes methane. The same thing with ethene, ethyl, and so on. So I hope you grab this concept and you can give more example to that. So it's something very, 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 very easy. So this serves as a substituent and this is on its own. So that's just it. And thanks for watching and hope you follow my video. Thanks again. I appreciate it. Okay. Have a blessed day.